Hi everyone. So in this video we will see two questions on convolution theorem. This is the first one and this is the second one. This was asked in GATE 2023 electrical question paper. So this was a very good question. First one is an easy problem. Okay. So how do you define a convolution? Let's assume that convolution of x of t and h of t is g of t. That is h of t convolved with x of t. Right. So the convolution would be, you will integrate, one of them remain as it is, but the axis will be changed to tau. This axis will also be changed to tau, but it will be mirrored into, here it will be d tau or dt. How will you remember it? Look, in the final answer I need t. In final answer I need t. So t cannot be variable. Sorry, t can be variable, but t limit of t cannot be defined because in the final answer I need t. T has to be there. So the limit has to be of tau. Right? So d tau will be there because sometimes people forget whether it will be t or whether it will be tau, right? But it will be here it will be tau, right? Because in the final answer we need t, so the integration has to be with respect to tau, right? Okay, and the other formula can be written in two ways. It can be x of tau can remain as it is and this may change, h may change, h will be changed to this, right? These are the two formulas. Okay, now let's understand a zero level concept. We will get back to the problem, but let's understand a simple concept. If this s of t is given to you, you need to write s of minus t plus 2. So most of you guys, how do you write it? You write it in this way. How will you do? First you will left shift this because it is plus 2, so you will left shift this. So you will shift this to here by 2. That means it will be shifted, 3 will be shifted to 1 and 4 will be shifted to 2. And then this negative sign is there, so you will take a mirror. So finally you will take a mirror and that will lead to minus 1 to minus 2, right? So this is how you guys do it. There is one more method, okay? This will be used highly in case of convolution. That's why I am telling. You can start from here as well. First what you will do, first you will mirror it and then there is plus sign, so you will right shift this. First you will mirror it because of this minus sign. First you will mirror it because of this minus sign and then you will right shift. Are you getting my point? So first if I mirror this, what will happen? This will minus 3 to minus 4. Then I will right shift this. Right shift by 2. So it will become from minus 2 to minus 1. Are you getting my point? Did you understand? This is the general formula that you should always start from here. First plus 2 is there, that means you have to do left shifting. Left shifting we did from 1 to 2, we have our function now. And then there is this mirroring. So we mirrored it, minus 2 to minus 1. But there is one more formula. You can start from here as well. So first what do you see? Mirroring. So you mirrored it. But there is plus 2. Now this time you will do right shifting, not left shifting. Okay. This time you will do right shifting. Okay. So this is one simple concept that I wanted to tell you all. Okay. So in these problems, what we are doing, first this h of tau remains as it is. This is h of t, so we will just change the axis. So h of tau will remain as it is. X of t will, first it will be mirrored and shift by some value. Here they are asking at 2, so it will be shifted by 2. So let me write down the value of g of 2. They are asking the value of g of 2. So what will be the value of g of 2? It will be, let's assume h of tau remains as it is, then g of 2 minus tau d2. Now what was your h of tau and what was your g of tau? H of tau was from 0 to 6. And what was your g of tau? It was also from 0 to 6. right? This was your g of tau. But what you have to multiply? You have to multiply h of tau with g of 2 minus tau. So one thing you can do is that you can start from here, g of minus tau plus 2. So you can start from here. First you will left shift and then you will mirror it. Or what I can do, I can start from here as well. First I will mirror it, then I will right shift. So if I mirror this, this will come here and then I will right shift. So how will my g of 2 minus tau will look? This is mirrored and this comes here. So it will look like this. This gap remains 6 only. So this will be minus 4. This will be 2. And this point will be 1 by 2 versus tau. Now these two are being multiplied and then we need to take the area. So if you multiply this function and this function, what you will get? Multiplication. What you will get? Multiplication of these two. What you will get? Only this much of function, right? That's it. Only this much of function. It will be multiplied with 1 only. So only this much of function you are getting. So let's assume this one I am calling as GHIJKLM m of tau. Okay, I am calling this as m of tau. So this is my m of tau, right? Now what do I need to do? I just need to calculate the area of this. That will be my final answer, right? So my final answer g of 2 will be 1 by 2 into base into height. Is there something wrong that I did? No. So my final answer is 1 by 2. So that's it. Are you getting my point? So these kind of question will take less than 1 minute if these kind of question comes in exam. What you will do? You just saw 2 seconds there. Okay. So what did you do? This one remains as it is. You just mirror it and right shift by 2. If there was minus 2, mirror it and left shift by 2. Okay. Mirrored, right shift by 2, just multiplication you can see, then you can simply find the area. That's it. Are you getting my point? So these are kind of question, if you know the concept very well, it will be solved very fastly in the examination, right? Okay, so let's move on to the next problem. So let's make some changes in this question, that x of t and y of t are given and the convolution z of t is maximum at t equals to t1 second. You need to find the value of t1. I will also make it is minimum at t equals to t2. Okay, find t2 value as well. Find t2. Okay, so you need to find the value of t1 and t2. It is maximum at t equals to t1 and minimum at t equals to t2. Okay, so how we will do it? Look, this function you are familiar, right? This function can be broken into u of t, right? So x of t you can write as u of t plus 1 minus u of t minus 1. This is your x of t. Are you agreeing to this point? U of t plus 1 minus u of t minus 1, right? So this is my x of t and I need to convolve it with y of t. Now I will tell you a very good thing. So let's first write z of t. Z of t will be y of t convolution with x of t. So y of t convolution with what is x of t? That is u of t plus 1 minus u of t minus 1. This is z of t. Now let's understand a simple concept. Let's assume a function g of t is defined as p of t convolved with ut. So what you guys do, g dash of t will be equals to p of t convolved with delta t, right? You take the differentiation ut. If you take the differentiation of ut, it will be delta t. Then for getting again gt, what you guys do, you guys make a running integration, right? Make a running integration g of t, just a second. Okay, in output you need t, so the limit has to be of t only. This has to be changed. In output you need t, so this would be pt, p tau, sorry, tau into whatever we get here into d tau. That's what you do, right? Now in this problem, what do I do is that I write z of t only. I write yt convolve with delta t plus 1 minus delta t minus 1 and convolution with u of t. This is what I am writing. Did you guys understand this point? Because convolution with any function, let's assume the function is m of t convolution with u of t is running integration only. Do you know this point? If you are convolving any function with step function, that means you are taking running integration of that from minus infinity to t. So eventually we need to take running integration of this function, right? So I just convolve it with ut. Are you getting my point? So this is what I can do as well. Okay, so like in theory examination it can be used, because in theory if you write z of t then you write zt, it will be a bit complex, so that's why I told this thing. Okay, then y of t plus 1 minus y of t minus 1 convolve with ut, right? Now what I can write, I will name this function as, what can I name now? p, u, everything is u, g, h is not used. Okay, h of t. Okay, so my zt is h of t convolve with ut, so it will be minus infinity to t h of tau d tau. Now what you need to do, you need to find the maximum and minimum value of z of t. That's you need to find, right? Z of t is maximum and minimum at this, so you need to maximize and minimize z of t, right? Maximize and minimize z of t. That's your task. And what is your z of t? That is running integration of h of tau. Now how to find the maximum and minimum? How to find the maxima and minima? You must have studied it in mathematics. How to find maxima and minima? You differentiate the function, right? Differentiate the function and put that equals to 0. So we will differentiate this and put that equals to 0. Now I now I can't tell the differentiation of this. Okay, now I can't tell the differentiation of this in this lecture only, because it will take around 10 to 15 minutes, but I will tell you a simple method how to write the differentiation of this function. Look, this differentiation and integration will be cancelled. The upper limit will go into the bracket. That's it. Nothing will happen to the lower limit. The upper limit will go into the bracket. That's it. That's the final answer. So your z of z dash t is, this upper limit will go into the bracket. That's it. H of t is equals to 0. Okay. Let me take one more example. Now, if they had asked you the differentiation of this, how would you do it? F dash of x will be, this upper limit will go into the t, that's it, x square minus 16, and for finding the maxima or minima you will put it equals to 0. That's how you find the maxima and minima of a running integration function. the upper limit will go into the bracket 1, whatever the variable is there. Here the variable was t, so it will go into the variable. So upper limit was t here, so that went into this function. So it became h of t is equals to 0. So what was your h of t? You need to put h of t equals to 0. So that means this you need to put equals to 0. That means y of t plus 1 minus y of t minus 1 should be equals to 0. Now what is our y of t? That we need to draw. This is your z dash of t. What was our y of t? Okay, let me pause the video and draw it. So this is our y of t. Okay, and from here we understand one thing, that our z dash of t will be maximum or minimum at this condition. Y of t minus 1, sorry, y of t plus 1 minus y of t minus 1 is equals to 0. That means y of t plus 1 is equals to y of t minus 1. This is the condition. Okay, so let's draw the graph of y of t plus 1 and y of t minus 1 and see where they cut. Okay, so on one page only we will draw the graph. T plus 1, that means left shift. Okay, so this is y of t plus 1. This was 0, this was 2, this was 4. Okay, this value is minus 2, this value is plus 2. And now we will make y of t minus 1, because we have to equate both of them. Y of t minus 1, that means it will be left shifted. So from 2 to 6 it will come. So it will be right shifted, not left shifted. It will be right shifted. Right, so this value is minus 2 only. Now tell me at what point the graph is cutting? At 2 and at 4. This is y of t minus 1. So y of t plus 1 is equals to y of t minus 1 at t equals to 2 and at t equals to 4. So both of the graphs are equal at t equals to 2 and t equals to 4. You can check here as well. Like what will, if you put t equals to 2 here, that means y of 3 should be equals to y of 1. Is it equal? Y of 3 should be equals to y of 1. Yeah, it's equal. 0 you are getting, right? And if you put 4 here, that means y of 5 should be equals to y of 3. If you put 4 here, that means y of 5 should be equals to y of 3. Are they equal? Yeah, they are equal. Y of 5 is equals to y of 3. So value of t1 and t2 are 2 and 4. Now you don't know whether the value of t1 is 2 or 4, or whether the value of t2 is 2 or 4. You just know one thing, that t1 will be either 2 or 4 and t2 will be either 2 or 4. Now you need to find which value is what. Okay, so what you need to find? You just need to find the value of z of t at t equals to 2 and t equals to 4. Z of t at t equals to 2 and z of t at t equals to 4. That you need to find. That's it. That's my target. Then I will get to know whether it is maxima or minima. So what was my z of t? What was my z of t? So this was my z of t. Or I can write from here as well. Yeah, I can write from here as well. My z of t was y of t convolve with x of t. Okay, let me copy that. Yeah, so first we will find the value of z of 2. So what will be our z of 2? Z of 2 will be limit of tau, that will be same. Let's keep y of tau as it is and just replace this as x of 2 minus tau into d tau. So now you can think about it. First I will mirror it, it will remain as it is, then I will shift it by 2. So this 0 will come at here. Are you getting my point? What will be my x of 2 minus tau? My x of 2 minus tau will be, first mirroring, mirror will remain as it is and this 0 will come here. The center will be shifted by 2. So this 1 will be at 3, this minus 1 will be at plus 1, this 0 will be at 2. So this will be your x of 2 minus tau with the magnitude of 1. Right? Now you need to multiply this function with this function. From 1 to 3 the magnitude is 1, otherwise it is 0. From 1 to 3 the magnitude is 1. From 1 to 3, from here to here the magnitude is 1, otherwise it is 0. That means it will be multiplied with 0, all of them will be multiplied with 0, only this much area will come and you have to find the area of this, then you will find the value of z of 2. Are you getting my point? How did I calculate z of 2? How did I calculate? Y of tau into x of 2 minus tau. So first mirroring it and then shift by 2. So first I mirrored it and shifting by 2. So this gave me this function. Now I have to multiply this function with y of tau. So I will multiply this function with y of tau. Y of tau will be this. So rest of them will be multiplied with 0. So 0, 0, 0. Only this function will be multiplied with 1. So the area will be half into base into half into base is 2 into height. Height is also 2. But the area is negative. So negative sign will be there. So the area will be minus 2. Okay. So the value of z of 2 is minus 2. Now you need to find the value of z of 4. Try doing it on your own. What you will do? Y of tau remains as it is. You will shift x function. First you will take the mirror, then you will shift by 4. Right? First you take the mirror, then you shift by 4. So if you shift by 4, then 3 will become here and 5 will become here. This will be tau x of 4 minus tau. And this magnitude is 1. And now 3 to 5, this 3 to 5 will be multiplied with this function. Now this function x of 4 minus tau will be multiplied with this function. With this function. So from 3 to 5 we are having 1. That means this much of function will be multiplied with 1. Rest of them will be multiplied with 0. So only this much area will be there. So what is the area of this? Area of this is, your z of 4 is coming out to be, area of this is half base into height. So it will be 2 only. So at t equals to 2 you are having the minimum value and t equals to 4 you are having the maximum value. Okay. So your minima, that was your t2 I guess, that is 2, and your maxima, that was your t1, that is 4. And the value also we know, the maximum value is 2 and minimum value is minus 2. Did you understand the complete problem? We understood a lot of things here. First thing we understood was, when we take the differentiation, we can convolve it with ut, so that we can take running integration. How to take the running integration? The limit will be from minus infinity to t, and the whole axis of t will be converted into tau. So minus infinity to t, m of tau d tau. Okay. So this function I am assuming it to be h of t. So my z of t will be minus infinity to t h of tau d tau. Okay. Now I have to maximize this. So how to maximize these kind of running integration? Just put this limit into the bracket. Okay. So whatever the variable was there, the upper limit will be coming to this side. Okay. So this differentiation of zt would become h of t only, and for finding the maxima or minima we have to put it equals to 0. So when we put it equals to 0, this is what we get: y of t plus 1 minus y of t minus 1 is equals to 0. That means y of t plus 1 should be equals to y of t minus 1. Then we had the graph of y of t, we draw the graph of y of t plus 1 and y of t minus 1. So the graph was cutting at 2 points, at this point and this point. We also verified it. Then we needed to find the value of z of t at t equals to 2 and at t equals to 4, so that we could know which one is maxima, which one is minima. So then we found the value of z of 2. How did we find? The function remains as it is, y of tau remains as it is. This x of tau is mirrored and then right shifted by 2. So right shifted by 2 and then multiplied with the y of tau function. Then we got to know the value is minus 2. Then again we need to find z of 4. That means y of tau will remain as it is, x of tau will be first mirrored and then right shifted by 4. Then we multiplied both of the function and calculated the area. Area came out to be 2. So from there we got to know our minima is at 2 and your maxima is at 4, and the minimum value was minus 2 and the maximum value was 2. So that's how we solved this problem. So this was a very good problem. I hope you understood a multiple concept in these two problems. Okay. So if you found the video helpful, please consider sharing it and liking it. Okay. Thank you.